audience. Hopefully we are live now. I'm not sure, but hopefully we are live now. So we would like to start our today's panel in relation with the AI and a very interesting concept, the concept of a smart city. I will start by making a parallel here. It is said that in order to understand the future, we shall look in the past. And the historians agreed that the main difference between a city from the 20th century and the city from 19th century, it was that the lights were always on. And that was due to a big disruptor, the electricity, which made the cities for the first time in history to never ever stop again. The same things happens nowadays, but the disruptor is AI. So like the electricity which came in the previous century and changes the cities forever, nowadays we have the artificial intelligence, which is coming again as a disruptor. We are getting comfortable with this disruptor, but we know that for sure this disruptor will change the cities again. It will make them smart cities, and we don't really know what a smart city is. We have some pictures or hopes or images, but in this panel we are trying to glue together these pieces and hopefully create an image. So together with our distinguished panelists, we would like to start to look a bit in the future. So our first panelist, and I would like to present you Annika Link, which from the Digital SME Alliance, which is one of the most trusted and stable partner of the data intelligence group. She will present us the European Union's perspective on smart cities along with risks and opportunities for SMEs. So Annika, the stage is yours.
Thank you very much, Marian, for this really inspiring introduction as well. And I'm looking forward to helping really indeed create some more understanding of these. I'm sharing my screen. I have to share my entire screen. I hope you can see it.
Yes.
Perfect. So my presentation today is going to focus on SMEs, small and medium-sized enterprises, in the context of smart city solutions and on the new proposed European AI Act. But before going into that, I would like to explain who we are. European Digital SME Alliance is a network of 30 members that are consisting of national, supranational, regional associations. Together,
we represent more than 20,000 digital SMEs across Europe. Our members are
our associations and clusters,
and we're very happy also to
always with CID, especially also for this really excellent event, for which I want to congratulate CID for organizing it, really at the forefront of technology topics and the green and digital transition. But coming back to digital SME for SMEs, so SMEs according to the EU definition, which means that they have less than 250 employees and less than 50 million revenue per year. We represent the SMEs in the ICT sector, so companies that are both producing hardware and software. And maybe just as an example, we have but also software solution providers. We have companies focusing on data and IoT services. We have IT consultants and also AI developers. And especially in the area of AI, we think it's really important here to support companies to build a network of AI innovators in Europe. And in the context of smart cities, AI is also really important. I will get to that later on. But we have launched this network of AI innovators of 140 companies from across Europe that develop AI solutions and that really lead AI innovation in different sectors, for instance, in logistics, agri-food, manufacturing, but also other areas such as intellectual property, computer vision, augmented reality, and satellite-based services. And they are at different maturity levels of AI usage and development. And with the focus group on AI, we're bringing them together to discuss policy, but also to exchange on different topics. And when asking or checking their activities, you can many of them are focusing on data analysis. They are, for instance, saying, yeah, we're doing data analysis or predictive analysis. We're working with big data, with smart cities as well. So some explicitly mentioned that. We are developing software in the area of AI, and yeah, they're really leading in these different activities. When it comes to their clients, the clients want to focus on business intelligence, on machine learning, on computer vision, but also in other areas such as natural language processing or robotics. And now you may be wondering why I'm telling you all of this, but when it comes to smart cities, data is really crucial here. Like a smart city, in my understanding, is really an environment where you use sensors and digital tools to make sense of the world. So you're trying to bridge the gap between the physical and the digital environment, and you're collecting information about, for instance, traffic or electricity in order to really gain efficiencies here. So according to different definitions here, a smart city is an urban area that uses different types of electronic methods to collect data. And then these insights gained from the data are used to manage assets, resources, and services efficiently. So AI SMEs can really have a crucial role here because they are developing these data services. When we look at the different activities in a smart city context, you have areas such as public transit, so traffic management, vehicle parking. You have public utilities and environment. So environmental monitoring, for instance, monitoring the quality of the air. You have smart waste disposal. You have the power grids. You also have public safety. There it's more about movement, but also crime detection. And you have public services provided by local administrations, so in the area of healthcare, but also housing, but also, for instance, schools, libraries, etc. So if we want to look at one example from the city of Amsterdam, for instance, they are saying that they're really using AI to become the eyes of the city, and they use it to analyze the growing volume of data, for instance, collected from street level cameras and other sensors. And they're connecting, as said here, they're bridging the gap between the physical and digital world. And the areas of application are, for instance, improving the roads, or just detecting decay in the city by taking photographs of the entire city, but also in the area of waste collection. So as an example from Amsterdam, this is what they do. And for SMEs, this can really be an area of where they can provide their solutions and provide these services. So we have a lot of companies in our wider membership that are already engaging with cities to offer solutions. So there's, for instance, a German SME that is providing AI solutions for energy management and CO2 reduction. You have a Belgian SME that is providing smart data management for the city of Antwerp. You have a Swedish SME that is using the phone image data and combining it with the data available on roads to identify the holes in the roads and to fix them, or to tell the city to fix them. And then you also have solutions from some of our members that are providing marketplaces to allow really to find really quality assured suppliers and etc. So it is a smart city can ideally really be an environment where SMEs can offer services to public authorities and citizens and become part of the smart city ecosystem. And they can deploy their solutions so they can use these activities that we mentioned before to work to develop these services for the city and with the city. And they can do that in a human-centric manner that is based on European values and that really takes into account also concerns such as privacy. And last but not least, they contribute to the local economy and boost innovation. So this is what we would see as benefits of a smart city that is really based on AI, SMEs working in AI and other technologies, of course, as well. Where, however, on the contrary, a risk that we need or that we think needs to be avoided is a platformization of the city. So what we have seen in the digital environment in general, where you have one large provider that becomes really dominant and that structures the information for society. So for instance, when you use a search engine and the way information is displayed would only go via this one provider. And also another risk that should be avoided is to lock in a local city only with a certain provider. So these are some of the benefits and the risks that we can see. I also want to talk about the upcoming legal framework on AI, because there may be some areas of activity in a smart city context that would be relevant to consider here. So the new proposed legal framework on AI, the European AI Act, it was proposed in April by the European Commission, and now it's going to the European Parliament and to the Council, so the member states of the EU, to discuss and to vote on it. And if it was to be approved, then it would become binding legislation in the next years. So not immediately, but maybe by 2023 or 2025 even. But what is important in this legislation is that it structures different areas of AI according to different risks involved with it. So and then it prohibits certain practices, and then others that are high risk are permitted but have to they are subject to compliance and ex-ante conformity assessment. And then you have other areas that are permitted and only subject to applications, and others that are permitted with. And what is interesting, I think, of course, this has to be studied a bit further, but if we look at the area of a like smart city context where you have some those would probably, from what I understand, be subject to compliance and ex-ante conformity assessment, because here it says that certain standalone AI systems, for instance, when it comes to access and enjoyment of essential private services and public services and benefits, would fall under this high risk. Here it's also about the management and operation of structure, education and vocational training, etc. So those would be the high risk areas. Then you have the ones that are really prohibited, for instance, general purpose social scoring. And here the example that has been given is that we don't want to go in the direction of, for instance, a country like China, where you have a social scoring system that allows you to, or that gives you a certain amount of credit or points, but if you behave in a certain way that is not approved by the government, you may be deducted points, and then this reduces your access to public services. So this would be prohibited under this new framework. And also mass surveillance would be prohibited. So remote biometric identification for law enforcement purposes in publicly accessible spaces. However, there can be certain exceptions here. And then things like exploitation and subliminal manipulation are also completely prohibited. And yeah, so I think it's interesting to consider the upcoming legal framework in the context of AI. To sum up, I think I want to stress again that really digital SMEs are enablers of innovation, and they can let Europe go in a different path that is based on an open ecosystem. And in the context of smart cities, they can really be part of the provider side, so they can provide these solutions. As mentioned, many of the AI companies, they're doing these data services and really developing solutions that are relevant in a smart city context. The companies, SMEs, they contribute to growth, to economic growth at the local level, and they can take on board European values and rules. So, as mentioned, the new upcoming AI Act, but also other types of legislation relevant in the digital environment. So, for instance, the GDPR, but also other types of legislation on privacy. So, Marine, with that, I would like to stop here, and happy to answer any questions that you may have.
Thank you, Annika. I would like to ask a few questions, and if the audience wants to ask questions, if we can address them real time, we will address them real time. If not, we will take them offline and respond to them. So, Annika, first of all, thank you for the presentation. It is encouraging to see that the European Union has a strategy for this and basically put regulation and practical best practices into smart cities and AI in general. So my first question would be, does European Union have any specific legislation for smart cities at large, let's say? And considering the fact that each process generates data, which is value, and in the context of smart cities, we are dealing here with publicly funded and generated value. Will this value come back to the people as well? So that's the first question.
Thank you very much for this question. So when it comes to the data generated by public institutions and services, there is the Open Data Directive or Public Services Directive, which is already, which was, I think, introduced in 2003, but now it has been updated to a public open data directive. And here the idea is really also to make this data from public services more available. Then this year, the Commission has also proposed the Data Governance Act, which is also a regulation that is supposed to support data governance and let people and SMEs have better access to data. So the national governments and administrations would also come up with some support to really share the data, to make sure that some legal questions are cleared out. So for instance, when you have mixed data sets where you have personal data that would fall under GDPR and some other data, how you could use that as a business. So to develop guidance on that. So the idea is here really to strengthen data sharing in the European economy by having these structures in place, and also by promoting data altruism. So by letting organizations, but also individuals share data. Of course, with certain safeguards to be sure that their personal, like the data protection, would not be infringed. So I think this is really important in the context of what we're talking about. When it comes to smart cities themselves, as far as I know, I'm not aware of specific legislation, but I would need to check. But what is of course relevant is also standard setting in this area, but this is also happening at international, but also at European level. And yeah, I hope I answered your question.
Annika, and with your permission, I would like to take a question from the audience. So basically, the audience is telling us that the information is power, true, and value as well. And what kind of security measures are taken into account against information getting into the hands of infractional terrorist groups? So in the European context.
That's a very good question. I think, well, there's the European Commission is of course also working in the area of information security. Sorry, because we're a business association, so just to be clear, I'm not, of course, not speaking on behalf of the European Commission. I'm just analyzing it from our perspective because we're following this type of legislation. But so the NIS directive is the key regulatory document, and here you have certain requirements to make sure that, for instance, public essential services and these kind of, as were mentioned here, maybe power plants, etc., would be protected, and to have certain standards in this area. So from what I understand, maybe an important point is also to connect these security requirements with initiatives in the area of like smart cities and data sharing, because indeed, if you open up all the information, I guess you also have more entry points for instance, terrorists, etc. But the NIS directive is taking care of the security part and should normally also include safeguards against that.
Many thanks, Annika, for the good response, for the good presentations. And again, we are happy that we saw the general picture, at least from the perspective of the European Union. Let's get also to the initiatives and applications done by Romanian universities. And I would like to welcome Mr. Adrian from Lucian Blaga, University of Sibiu, to tell us about the profile of his research group, and also what sort of application they have developed for smart city, for Sibiu as a smart city.
Thank you, Marin. Just I want to ask if you can see my slides. Okay, thank you very much. My name is Adrian Florea. I'm representing Lucian Blaga, University of Sibiu. I'm also professor there and with activity related to smart city. I represent also Hasso-Plattner Institute, which I leaded the Knowledge Transfer Center from Lucian Blaga University, and also I'm from last autumn member of the board of Cluj IT Board of Directors. I was involved in this research that I present today with my colleague Daniel Morariu, who is expert in artificial intelligence, machine learning, and text mining. We will discuss today about addressing some smart city challenges using artificial intelligence in order to create a healthy and safety environment for citizens. And we will express our challenges and approaches that we have done in Lucian Blaga University. I will shortly remind the strategic pillar of smart city and also the application that where we use some artificial intelligence algorithms targeting smart buildings, targeting smart electricity, forecasting production and consumption, smart and safety about face emotion recognition, and also with involvement in production or in other activity. But I will finish showing some case study about smart mobility using counting cars, ride sharing, and smart parking. As also Annika said before, smart city actually represents places where information technologies is combined with infrastructure, architecture, everyday objects, or even our bodies in order to solve some social, economic, or environment protection problems. Our few projects that I will express here are based around these 3-4 pillars: smart living, smart mobility, and also smart and safety for citizens, and smart environment. I start with our first application that was a research made in collaboration with Nova University of Lisbon, where we introduce a new methodology for modeling energy consumption based on occupation rate of the building and also the number of vehicles that are in a parking lot belonging to an institution. We intend to use the number of cars which are parked and reduce the investment in other monitoring solution. Of course, we use some hardware devices like laser beams or microcontrollers or developing boards from Arduino, but also we implement two artificial neural network in order to predict the building occupancy and then also with the energy of that building. And as we can see in the picture here, the forecasting is modeling quite good the actual load of the energy. We capitalize our work in some important articles, but
Adrian,
also
sorry to interrupt you, but it seems that your slide is not advancing, at least on my screen. Okay, now
I should start again then. Here you can see here the smart building, or it's
yes. Sorry.
Okay, please interrupt me in order to do the right things. Okay, our next application was based on using different artificial intelligence algorithms like Markov predictors or stride predictors or neural network predictors in order to forecast the electricity production and consumption in smart building. We use some data sets for 6 months from a household from Germany, where we have a different producer, two photovoltaic source and 3 consumers. As I said, we use different algorithms like Markov chain, and our results also was quite significant that the errors, it was around only 30 watts on the large period. Of course, we capitalize also this in some papers. I continue with smart safety and face motion recognition, where we implemented 4 features, let's say face detection, age and gender detection, also medical mask detection and face motion recognition. We start this research because there are a lot of activity in manufacturing sector where it is important to see if the employee is happy or is sad and can have something on his mind and cannot be very careful to what he has done regarding manipulating or automation some assembly lines or some activity in civil engineering. And as I said, we implement this for feature. Starting from images, we extract the landscape landmarks prediction, important points that are defining the face, the smile, the eyes, and also applying artificial intelligence algorithms like multi-layer perceptrons or support vector machine, or even we
Sorry again. but we cannot see the slide. They are not advancing. If you can maximize them, put in presenter view, that would be excellent. But otherwise, just advance the slide as well.
Okay, but how it looks now in order to don't
Yeah, looks better. If you can use presenter, if you can use showcase video, it would be the best.
okay.
But at least be advancing. Make sure you advance the slide.
Okay, just I hope it's better or a little bit better. Okay, then we use also some genetic algorithms in order to obtain the optimal structure of our algorithms or our networks, neural networks to predict. We also develop some trainings about this activity in our knowledge transfer center, and I hope now we see. Yes, I continue with something about smart mobility. Some important statistics that shows that more than a quarter of CO2 emissions are based on traffic and transportation, and also the road transportation is about 65% of those emissions. Also, European Environment Agency identified the transport as the biggest greenhouse gas emission. And in our research, we try to implement some algorithms regarding heuristic algorithm regarding measure and minimizing these NOxes, CO2, NOx, or CO. Problems like green vehicle routing problems or ride-sharing problems, and also we developed some hardware and software embedded system for monitoring air quality from the city. We apply and obtain European grants with Norway in this idea. We developed also a counting cars application and use a lot of image processing algorithms for detecting vehicles that passing in front of a camera. We test these algorithms in different scenarios from CPU, in the highway, in the roundabouts, or in other crowded zone. And we try to correlate this information about pollution and noise with the incidence of respiratory or renal or cardiovascular diseases, or even neurological, if we said about noise. Okay, ride sharing problem, we intend actually to group different vehicles based on their trajectory similarity. We use some pre-processing steps of data. We need to identify trips and then to create feature vector and apply similarity measurement and then clustering based on these similarity measures. We use some data from Dacos company for more than a month, and also create some graphs that shows which are the most important trips that could be grouped together of course passenger or drivers. But there are some factors that are against this concept, like passenger safety, especially in the COVID period, but also privacy, or sometimes users are more comfortable to walk with friends or friends of their friends. And I will start with our case study regarding smart parking system. The motivation is clear because I think there is no city where there are many parking spaces or don't have this problem, especially in smart cities. Of course, there are also different reasons, like important festival, like in Sibiu, it's a famous theater festival, but also some sportive activities like Red Bull Romaniacs, where also the administration provide the existing parking slots for guests and create a pressure for the population. Also, some studies show that we spend around 10 minutes finding a place for parking, but we can think to a solution, because as we also find in our previous research, there are some parking spaces inefficiently exploited, because could be in our case universities or banks or public service clinics or malls, when sometimes in different period of the day or of the week there are some empty spaces that could be shared by private institution. Which advantages could be created from smart urban mobility? Of course, finding immediately of a parking lot, we streamline the traffic, especially at peak hours. But also, we reduce the time for finding these places. From social point of view, we reduce, of course, the lost time from individual point of view, but also the fuel cost, and also with impact of reducing pollution and improving air quality. And of course, there are some economic incentives received by the companies or institutions that could share their space. Okay, that was an idea, and another our solution was based that in Sibiu, sometimes we are not a big city, but we reach sometimes 500,000 people based on local inhabitants or in transit or visitors when I said important festivals. But we have around 27,000 parking places. This is new data. That means we can have almost 18 to 20 people per car, per placing space. So we implemented this, or try to pilot this at Lucian Blaga University, where we also find that from the whole year there are only 40 weeks used these parking places. More than that, we have also weekends where we can share these spaces, or during some days after 5 o'clock afternoon we can share these spaces. We capitalize also in some papers our research, but which is the feature of our work? We can book through a web application, we can book some parking spaces. Of course, we can see this in real time. We can the entrance and the exiting is based on license plate recognition, and of course this will affect directly the database and the web application, which express to the large people the number of places, free, of course. We implement different costs for depending on the day or the hours when you use this, and the gamification concept. Of course, it is a hardware and software application using some hardware like camera, like Raspberry microcontrollers, motors, but also the software regarding web application, database, the license plate recognition algorithm. And also we use a new feature, we introduce in our feature the idea to find the geometrical particularity of the park, and for this we use image processing and like half transform or machine learning for detection of object, thermovision camera, because we think that we can find the occupied places based on dissipated of amount of heat, but also finally we use our own motion detection algorithm. As I said, few algorithms about license plate recognition but based on Google Tesseract library or different languages, OpenCV and others. This is our results from our research with the all three algorithms, and also how it looks the application of ALP ALPR for recognition of the number of the cars. We have some limitation for the moment, depending on the camera that we use. Of course, we have a higher or a lower accuracy, but also we still don't know where will be parked that car, because we don't use sensor. We use only the visual aspects. Need to implement the payment, but also to treat the scalability issues. Of course, our next projects is intend to find enough data and store that in database in order to may apply data analytical tools to forecast events like environment condition and pollution, and also use this information, as Annika said before, for creating a platform for a city to help, like we have information when we buy a house or when we build a hospital, to know exactly the utilities, to know exactly the water, the gas, the electricity, but also to know how polluted is our city in that town, in that sector. Of course, we also continue our work about smart parking sharing, and to find the solution for uniformization, how to enter in the not only by ALPR algorithms. And of course, we intend to continue with correlation with medical problems. And the most important things, or one of the most important things, is to have open data, and can be used, as also Annika said, by SMEs and other interest party to foster the digital transformation in every pillars of smart city. We initiate some public-private collaboration for generating such of open data, and of course is a personal invitation for all of you to have this fruitful discussion in Sibiu Innovation Days in this autumn, which is the little brother of Cluj Innovation Days. So this is my briefly activity. I'm waiting for your questions.
Thank you, Mr. Adrian. Very good. Very interesting things happening in Sibiu, I would say. So, if there are any questions from the audience related to the topic, I will take them. If not, I would like to ask two questions. First question is, what sort of challenges did you have with collecting the data, and how did you overcome that challenge, those challenges? So.
Yes, indeed, as in every research or research that is based on engineering activity, is very important, or validation of the hypothesis of your research idea. You need to collect data. You need to collect enough data to can apply some machine learning algorithms. So collecting data, anonymization, processing, identifying some outliers and removing is also very an up-to-date, let's say, challenge. So of course I present different research. When we discuss about electricity, we have data provided by a private household that it was a master student that came from Germany and studied in Sibiu, and he provide this data that we can apply. If we said about air quality and the environment solution, we developed our own hardware software devices and use in our cars and go in different places of the city. But of course, it's a pilot. If we discuss about parking lots and parking counting, it's about Sibiu ULBS, because for this reason it's important to have open data to can apply on different data your ideas and to see if it works or it fits. And of course, the human resource is another challenge, because as most of us, I think, know, in IT it's very difficult to have PhD students, because they are attracted very much by the industry sector. And of course, PhD is a prolonged crisis of identity, and it takes 3 years, and this is not easy to. It's based on passion of our student, our former students that work with us, and maybe it creates some special relationship and they want to continue on this work.
Mr. Adrian, many thanks. And the second question, and let's try to be brief because we have other two big presentations and we want to use the kindness of the organizers to their thing. The second question is, how do you see the, let's say, social, economical utility and sustainability of your solution?
Yeah, actually, as I said, we need data from medical system in order to correlate with what we create something from technical part. But also, based on the CBU Innovation Days, we continue our work and create the local council of CBU municipality, a commission which is dedicated for digitalization and smart city. I am part of it, but also we developed a working group which is composed by digital leaders of IT companies, from NGOs leaders, but also from people who work in traffic, who work in environment, who work in police, in order to find some important problems to solve or to propose to the administration to take into account.
Adrian. Now let's move to another big university, Babelsberg University, and we have Ms. Camelia presenting the research group and the solution. Even if we go into the lunch break pause, we will continue with all the presentation. Don't worry. We will have time for
Hello, thank you very much for this invitation, and I am happy to be here today to present our research in this field of applying artificial intelligence to smart city challenges. Let me share. I have prepared a few slides that I would like to share. Just 1 second. Okay. Can you confirm if you see the main slide or not? Yes.
We see that, but it's the presenter mode. So, okay.
What about now?
Okay.
Yes, good. Okay, so as I said, thank you for this invitation. My name is Camelia Kira. I represent Babes-Bolyai University in Cluj-Napoca. And the topic of my presentation today is to present to you a few artificial intelligence models that we have developed as smart traffic solutions. The outline of my presentation today is to first introduce a little bit the research that we carry out in the field of artificial intelligence or using AI models for different complex problems from the real world. Present these main AI directions to give you an overview pictures of the research that we do, and then focus on the main part of the presentation on some concrete and specific AI solutions for smart traffic. And I have selected 3 such solutions. One of them is for urban bicycle renting systems. The second one is a solution for assigning traffic in large cities. And the third one is an AI solution for finding optimal routes, specifically tailored for electrical vehicles. And of course, I will conclude with some final remarks and directions for future work. So to start with an introduction of the university where I come from, I represent Babes-Bolyai University, which is it is the oldest and now is also the largest university in Romania, having an academic community of about 50,000 people. Starting from the year 2016 until now, Babes-Bolyai University also holds the highest position in Romania in the university meta ranking. And the Faculty of Mathematics and Computer Science, where I come from, is an important faculty in this university, one of the 21 faculties the university has. We have two departments, one of mathematics and one of computer science, and I come from the Department of Computer Science, which has 61 permanent members and many associated collaborators, and 54 PhD students, out of which I would say more than or almost half of them work on research that involves artificial intelligence or the use of AI tools. This can also be visible by the high number of members that the largest research institute on artificial intelligence that we have, called Applied Computational Intelligence Research Institute, has. This is a research institute organized in 4 large AI research groups, each focusing on a specific topic. We have one on computational intelligence, another on machine learning, another on data mining, and the 4th one, which I'm also part of, on metaheuristics and for complex systems. At the level of teaching in the Faculty of Mathematics and Computer Science, besides the AI compulsory courses that we have at the undergraduate level, we also offer several optional courses for students at both bachelor and master level, which present AI elements, models, and solutions for specific fields. For instance, I would mention the course AI for Social Good, or the course Introduction to Automated Driving, which is implemented in collaboration with industrial partners, or AI Models for Climate Change, or the course Social Network Analysis, which presents network science tools to analyze data that can be modeled as complex networks, and using also AI tools. At the level of master, we offer 2 programs using AI research. One of them is well-known, Applied Computational Intelligence, and the other one is new. It will start in the autumn of this year. It's called Data Science for Industry and Society, and it's targeting not only computer science students, but also students coming from other fields wanting to know about how to apply artificial intelligence methods in order to analyze data and make predictions. Regarding other research projects, I have selected here only a few to show the variety of projects that we have. We not only work on smart city solutions, we also have other ongoing projects using AI. For instance, in the QA screen projects, we develop a decision support system to ensure the quality in breast cancer screening and to classify images given as mammographies. In another project, which is a bilateral collaboration between Romania and Norway, we develop deep learning models in order to improve the performance and reliability of national weather warning systems. And I have here a 3rd example of such projects in which deep learning models are developed in order to improve the quality of software systems and predict defects. So clearly, all of these examples wanted to emphasize the kind of interdisciplinary research that we carry out, in which AI models are not only used for the smart cities and challenges that I have selected to present in today, but also they are used in the fields of health and medicine, in finance, in biology, psychology, and many others. We have many ongoing projects involving both academic partners and industrial partners, in which we try to develop solutions that are specifically tailored for the challenges in all of these different fields. Moving on to the main part of my presentation today, as I said, I have selected 3 solutions that we have developed in collaboration with other partners. The solution for urban bicycle renting systems involves the development of a computational intelligence method for optimization that has been developed in collaboration with 2 institutions from Spain. The solution for traffic assignment is using a multi-objective evolutionary model and has been developed and tested for data in a collaboration with a university from Brazil, from the south of Brazil. And the solution the AI solution for optimizing routes for electrical vehicles is again a part of a collaboration project with a technological institute in Spain. So allow me to start with the first one. I would like that for each one of them, I will present you overall what was the challenge and how we developed the proposed AI solution in order to address that challenge. The first one, the urban bicycle renting systems. We all know these public renting systems in the city. In this project, we were offered data collected from the cities of Valencia and Barcelona in Spain, and we were given data about the location of the bicycle base stations, how many bicycles could be attached to each base station, where is the location, how many, and the data about the storage centers where bicycles were kept for either repairs or would be gathered from some bicycle base station. The idea and the challenge here was that a solution was necessary for the optimal routes for vehicles servicing this bicycle base station in the city. There are several vehicles available, each having a certain capacity of loading bicycles, and each base station from the city had a demand, a certain demand of either picking up bicycles that needed to be repaired or the need to be for new bicycles to be delivered in order to ensure that a bicycle base station is as full as possible with available bicycles. The solution, first of all, we took this problem and the first step was to model it as a vehicle routing problem with certain characteristics. So we had a capacitated vehicle routing problem because each vehicle that could transport bicycle had a certain capacity. Multiple depots because we had 2 storage centers, and it was a VRP with pickup and delivery because we are not only interested to visit each bicycle base station on the shortest possible route, but also to respect the restrictions about the demands of the bicycle base station and the capacity of the vehicle. So the solution was modeled as a route for each of those vehicles, and an evolutionary model was implemented to find that optimal solution because the number of possible solutions was very high. The complexity of the search space is clear. We choose to evolve a population of potential route solutions, which would be evolved according to evolutionary rules, using selection strategies, crossover and mutation operators, and in this entire search process would be guided by a fitness function looking at the total cost of the routes involved in the solution. Regarding computational experiments for this problem, we have applied our proposed solution for data provided by our partners, in which we were given the number of base stations, the capacity of each base station, the capacity of each storage center, the number of vehicles, and the load capacity of each vehicle. In this map, we have the storage center marked with the circles, and the rest of the points are base stations. And the idea is to see in different scenarios in which we have different demands for each base stations, how we are able to improve the solution that is reported by our approach. And if that solution is obtained using limited computational time. And for here we depict only 5 such scenarios, but we performed experiments for many scenarios in both cities and show how the solution was improved and overall cost reduced for servicing the base station. The second example that I would like to show refers to the problem of traffic assignment. Here, the challenge was to minimize the average travel time for all cars involved in a traffic setting. We are talking about large, busy cities in which there are several trip requests made from the same origin point to the same destination point. This is the simulation data that we have received from our university partner in Brazil. It models, in fact, the intersections in the cities as nodes in this graph. and the distances that we have between two nodes represents the cost of using that edge in the trip. But the complexity and the challenge of this problem comes from the fact that we have a lot of trip requests for the same origin-destination pair. So for instance, here A and B represent two home residence areas. L and M represent two attraction areas on a Saturday morning. And there are in total 1,700 trips in this simulation that are being requested for the same for these four origin destination pairs. So here the challenge is not to determine the shortest path. We know what is the shortest path, but distributing the vehicles in the environment is the challenge, because selecting for each vehicle, for each car, the shortest path would mean traffic jams, and would mean that in fact the travel time for each edge is increased by a certain amount for each vehicle per hour of flow. So the challenge was how to distribute the cars in the traffic in order to minimize the overall average travel time. This is again a very complex problem with a very complex search space, and the proposed approach here was to consider multiple objectives in an evolutionary approach. So we tested here several models. Two of them are given here. In the first one, we had 4 objectives, one for each origin destination trip, so to minimize the average travel time for each origin destination trip. And the second one is to consider only 2 objectives. One is to minimize the average travel time for all the vehicles, and the second one is to take the worst travel time and try to minimize that as well in the same time. The experiments here were performed extensively for different combinations, as I said, and different parameters in the model. And we always have a solution improvement obtained to the all or nothing approach. Here, for instance, the improvement was 27% for the average worst model. Our solution does not only provide the best distribution of cars, but also provides this so-called Pareto fronts, based on which we are able to select that solution that optimizes all objectives considered in the same time. So these are given for both models considered in the experiments that I have shown in these 2 slides. Finally, the third AI solution for a smart city challenge that I wanted to show you, it refers to finding the optimal routes for an electrical vehicle for its current location to a charger location, in order to take into account the energy consumption of that electrical vehicle. So we are not interested to find necessarily the shortest route or the shortest in time or in distance, but that route that optimizes consumption and leads to a tailored solution for an electrical vehicle.
Basically, end of it, if we can speed up a bit. I'm sure it's excellent, but let's continue to use the speed of the bit.
Okay, can I continue? I'm very sorry, Marina, I couldn't understand what you have said.
We are closing to the end of the tutorial, so if you can speed it up a bit.
Okay. Okay. Okay, so the solution proposed here is based on case-based reasoning and an algorithm for finding that optimal route. Here, we took the data that is shown here is from the city of Burgos in Spain. This is actually the city center in Burgos. And our route selection algorithm took into account the special characteristics of the route, which would penalize different characteristics in the route. So not only the route distance was taken into account, but things such as the number of changes in the slope of the route, or the overall altitude increment, or the number of traffic lights, roundabouts, and so on. So based on this, we are able to calculate a penalty of the solution, and we compared that with the solution provided by Google Maps. Google Maps is shown here in dotted line, our proposed solution in a continuous line. And we always have, in every scenarios that we considered, we have a lower penalty, sometimes even 10 times lower, as seen here in scenario number 1. We considered many different scenarios, taking into account different times of the day, of the days in the week, environmental conditions, and so on, in order to validate what we have proposed. Okay, and to conclude, I would like to mention on this last slide other ongoing related research directions that we have that relate to other smart city challenges. So for instance, autonomous driving, or using machine learning techniques to detect pedestrians, traffic signs, parking spaces in the city. These are all ongoing projects that are developed in collaboration with other partners, including industrial partners. And it is something we are very much interested in, attracting funding for developing projects of an interdisciplinary nature with other academic and industrial partners. Thank you very much for your attention.
Thank you, Camelia. Hopefully you can hear me well because you cannot hear me that well, but hopefully you can hear my questions. Basically, I will ask the same questions. Any challenges in the data collection and long-term sustainability, but let's be brief because we are going to the other.
Unfortunately, I think I have some technical problems because I could hardly hear what was the question, Marin. Maybe you can use the chat, or you can repeat it for me. Challenges for data collection. Okay. The challenges, yes, of course, there are always in this kind of research where you want to apply methods for analyzing artificial intelligence solutions for real data collection is a problem. And we have addressed this by, we were lucky to be able to get this real data from the industrial partners involved in our project. And we're able to conduct the experiments and provide, the solutions not only for experimental data or for benchmark data, but also for real data collected from the city. That was really, really important. I would also add to this challenge of data collection because I have presented a lot of the challenges of our AI solutions. I would add not only the challenge of the problem, but the challenge of finding that AI model or algorithm in order to have a good enough solution or an optimal solution using computational time as minimal as possible. So this always has to be addressed by making many preliminary experiments, and what I have showed today represents in fact the best working model, but we have tried in our preliminary experiments different components. We have compared them, make a throughout analysis, and then selected the best working solution, AI solution for the specific problem at hand.
Thank you. Thank you, Camelia. Can you hear me well now?
Yes.
I just refreshed the page, so it's not the microphone. Anyway,
Okay.
Let's go forward. Thank you very much, Camelia and Delia. We will just go into the time for lunch break if needed, but have your presentation in full and looking to hear you.
Okay, hello, thank you very much for your invitation. I am glad to be now in this meeting and to present. Let me perform screen sharing. Okay, so slideshow. So my name is Delia Alexandrina Mitria. I am with the Computer Science Department, Technical University of Cluj-Napoca. And I also represent the Brain City group of Cluster Cluj IT, which has close collaborations with our university, who develops a complete smart city solution that was also presented yesterday in a specific panel. Today, I will sustain the presentation with the title Data and Image Intelligence Impact in the Domain of Computer-Assisted Diagnosis and Robotic Surgery in Smart City Context. Here are the topics I'm going to present. First, an introduction, then I will stop upon 3 specific use cases for computerized medical images, like tumor recognition and segmentation within ultrasound images, a computer-aided surgery use case referring to advanced tumor destruction through minimum invasive procedures, and also COVID-19 recognition use case employing information from computer tomography images. Then conclusions and future directions for development. The Technical University of Cluj-Napoca is an advanced research and education university, high degree confident university, as it was awarded with the Order of the Ministry of National Education in 2011. Its mission is to develop value in people, processes, and products. As its structure, it contains 12 faculties, which are grouped in 2 main centers in Cluj-Napoca and Baia Mare, also having extensions in Alba Iulia, Bistrița, Satu Mare, and Zalău. The technical university, our technical university, has a complexity of profiles such as computer science, technology, electronics and electrotechnics, telecommunications, architecture and civil engineering, also robotics, industrial and environmental engineering, but letters and sciences as well. Technical University maintains close relations with the economic environment, which allows a rapid integration of the graduates in the labor market. And another very important aspect is the integration in the European and world context, our university being a member of the European University of Technology Consortium, involving many European universities, and this fact has impact at both didactic and research levels. I am an associate professor at the Department of Computer Science, Technical University of Cluj-Napoca. I have performed PhD and postdoctoral studies in the domain of advanced solutions for e-health, focused on image analysis and recognition, also for virtual biopsy. But data intelligence for the detection of the pathological stages within medical images was approached as well in my postdoctoral studies. I belong to the Image Processing and Pattern Recognition Research Center of our department, who has as domains of interest autonomous driving, detection of celestial bodies, face recognition, computerized medical imaging, and structured reporting. Since I am focused on computerized medical imaging, I have presented here the is part of our research group. We collaborate with medical specialists from the most important medical institutes of our city. We have been involved in many research projects, both national and international, targeting many medical domains. But today I will insist upon the achievements of the project IMPROVE, an acronym for high accuracy innovative approach for the robotic assisted intraoperatory treatment of hepatic tumors based on imagistic and molecular diagnosis. In this project, I have been the leader of the computerized medical imaging team. The main objectives of our research are to develop computerized, also non-invasive methods in order to perform automatic and computer-aided diagnosis, and to develop methods for computer-aided surgery as well. Our main challenges are that of overpassing the limits of human perception of the physician, and also of the currently existing medical techniques. Also to gain optimum performance for them. We target both domains of computer-aided and automatic diagnosis, which are still interleaved. Computer-aided diagnosis involves the participation of the human, and it can be considered safer, while automatic diagnosis is focused on algorithms, so the computer will make the final decision. 100% accuracy should be improved, should be achieved, but this is very difficult to be accomplished. So always we need to improve our methods. All this is done in the smart city context, in the domain of e-health, targeting to improve the quality of life of the people affected by pathologies through non-invasive, non-irradiating, non-expensive, repeatable procedures, and also to reduce malpractice. Concerning computer-aided and automatic diagnosis within medical images, we have focused on severe medical affections like tumors. Tumors are among the leading causes of death nowadays. Hepatocellular carcinoma is the most frequent malignant liver tumors. So many of our research is about hepatocellular carcinoma. The biopsy is still the most reliable method in order to diagnose this kind of affections. It is the golden standard, but it is invasive and dangerous, as it could lead to infections and to the spread of the tumors within the human body. That's why we develop non-invasive methods, computerized techniques to be applied in ultrasound images. Ultrasonography is a medical investigation technique which is non-invasive, non-irradiating, not expensive, so it is repeatable and suitable for patient disease monitoring. We have approached two directions. The newer one based on deep learning, and the conventional one based on deriving image features like textural features and combining them with conventional classifiers. Here we have some relevant ultrasound images for cirrhosis, which represents a first phase of parenchyma restructuring, then HCC in incipient phase, which is smaller, and HCC in advanced phase, which is larger and usually heterogeneous. We aim to perform both diagnosis and segmentation. So diagnosis means to identify the presence of the disease by classification algorithms. Usually we have selected a region of interest in the targeted area, and the class is provided by our algorithms. Also, segmentation means to identify the contour of the structure, to localize it inside the organ, and to estimate its expansion in the organ. The conventional approach consisted mainly on building the imagistic textual model of various affections. This targets virtual biopsy, so we aim to identify the disease, the properties of the tissue, and also the evolution phase. We have computed textural features which approximate the statistical properties of the gray level. Thus, they provide indications upon the structural and physical properties of the tissues. We performed in the learning phase relevant feature selection by specific methods, and we determined the specific values of the relevant features. During the validation phase, we applied powerful classifiers which received at the input the values of the relevant textual features. The performance was assessed in terms of accuracy, speed, and stability, and the best performing conventional classifiers were multilayer perceptron, support vector machines, random forest, but also AdaBoost meta classifier combined with decision trees. We more recently approached deep learning, mainly convolutional neural networks. These networks perform in the same time image analysis, dimensionality reduction, and classification. We have developed an original architecture in order to improve the accuracy, beyond the state of the art if possible. Similar researches were performed by specialists from world universities like Florida, Montreal, also Technion Institute of Haifa, Israel, researchers from Italy, India, and China. In our newly defined architecture, we considered convolutional layers of various sizes, also dilated convolutions. An atrio-spatial pyramid pooling module was employed as well, and thus finally we obtained multi-resolution features. The best accuracy resulted was 91%, which overpassed the results obtained with classical CNN, and also those based on textual features. Here we have the assessments for two data sets gathered with two different ultrasound machines. We further improved HCC recognition by combining multiple image modalities, such as B-mode ultrasound images and contrast-enhanced ultrasound images. We designed hybrid multimodal classifiers combining multiple convolutional neural networks by these fusion schemes. The best achieved performance was above 98%, and we had a new approach to our imagistic model through the feature maps provided by the convolutional part of the networks. Here are the results of HCC segmentation through CNN, the best resulting accuracy being above 70%. In the grayscale part, we have the delineations of the medical specialists, so the ground truth. And we have here the confidence maps with blue and red. With red, the tumoral pixels are marked. We also approached methods for computer-aided surgery, aiming to perform advanced HCC destruction. Advanced HCC is a large tumor, difficult to be treated by classical surgical methods like the usual elimination or resection. So minimum invasive laparoscopic procedures are to be implemented, which are assisted by a specialized robot who has to inject a harmful substance inside the tumor. Through our methods, we developed a simulation environment in order to yield safe methods for the patient life, and also to improve the efficiency of the treatment. Thus, we have generated the 3D anatomic model of HCC by applying HCC segmentation by CNN in combination with a 3D reconstruction method. Also, another target which still has to be developed is to detect the main blood vessels within the tumor. These blood vessels should be avoided by the needle in order to keep the patient safe. Our application also allows to interactively build the needle trajectory through the liver and tumor by mouse click. Based on the 3D anatomic model and on the corresponding sections that can be, 2D sections that can be extracted. Okay, last but not least, we try to perform COVID-19 diagnosis within medical images. COVID-19 diagnosis is a hot topic nowadays. The PCR tests are still the mostly applied methods. They're providing an accuracy between 70 and 80%. This is low and should be improved by data intelligence. We developed CNN-based methods in computer tomography images, and we succeed to increase the previous accuracy by 7.74%. And also by applying an adversarial graph learning method in order to improve the learning process, the results were better than when employing the CNN alone. As we can see this in our confidence maps, when employing adversarial graph learning, the detection is a lot more accurate. Okay, so as conclusions and benefits, I can say that our automatic diagnosis systems and also the methods for computer-aided surgery improved the diagnosis accuracy, but also the efficiency of the treatment. The corresponding methods being non-invasive or minimum invasive, so comfortable and very safe for the patient. The future directions are many. The most important being to gather more data in order to further improve the performance. Also to perform further combinations of multiple image modalities, multiple medical image modalities. Another target is to employ non-imagistic medical data and to study the combination between non-imagistic medical data and imagistic medical data. Another applicative target is that of preventing cancer, so detecting the phases preceding cancer, so the pre-neoplastic stages. Okay, so this was my presentation. Thank you very much for your attendance.
Thank you, Delia. A very, very good presentation. And
Thank you.
I would like to ask the same questions, in fairness. So, especially considering that you have dealt with medical data, what were your challenges?
Okay, so our challenges are to gather more data, of course, respecting the standards and regulations referring to the patient safety and confidentiality. However, if not very much data would be gathered by our physicians, if not very many cases of cancer exist, maybe we should be glad. But we should find a compromise between the complexity of the CNS and the size of the data sets.
The second question, for fairness as well, how do you see the long-term sustainability and social benefit of the solution you propose?
I see it in a very positive light. So I think our methods can improve the quality of life of the patients and the safety of their lives when they undergo surgical procedures. Okay, the accuracy of the diagnosis is, of course, very important, but I think we will still allow the physicians to interfere. However, we continuously improve our methods in order to get the highest accuracy possible.
Many thanks, Delia. Many thanks to the panelists as well. We have to close. I would continue the panel for a very long time, but still we have a limit here. Well, to paraphrase one of my colleagues who said he will go smarter home, I would say I will go prouder home. Now seeing that there is a strategy in place and seeing that we have here good specialists, good researchers that can create value and that can compete on the international level. It's also a tribute and a homage to those educators, professors, teachers, that unbroken chain of people that took care that there is somebody else to to carry on the light of knowledge. Thank you very much, and we might see each other the next year, hopefully discussing AI again. Thank you and goodbye to you and
Thank
to the
you. Thank you as well.
as well.
Bye.
Goodbye.
Innovation Days is part of the Future Skills lifelong learning program. The project is co-financed from the European Social Fund through the Human Capital Operational Program 2014-2020.